Welcome back, fellow explorers, to our deep dive into the mysteries of Mercury, the closest planet to our Sun. Last time, we ventured into the harsh, volatile environment of this rocky world and encountered five incredible, hypothetical creatures that defied everything we know about life as we see it on Earth. From the elusive Cirrusterium to the glowing Occulixis, these creatures showed us how life might adapt in one of the most extreme environments in our solar system. But the story of Mercury's alien ecosystem doesn't end there. Today, we continue our exploration as we uncover five more fascinating creatures that could inhabit this unforgiving world. Each one is a marvel of adaptation, thriving on Mercury's intense heat and frigid nights. The first creature we're looking at today is the Ignifelis arden, better yet known as the blazing cat. It's a small cat-like predator, about 2 feet long, with fiery orange skin and thick, heat-resistant fur. The skin of the Ignifelis is covered in a dense multi-layered dermis that reflects solar radiation. Its internal cooling system circulates fluids near its skin, keeping its body's temperature stable despite the heat. Its claws are retractable and razor sharp, designed for quick strikes. The Ignifelis primarily feeds on smaller animals like Cniferous and Noctiluxes. Its diet also includes some extremophile insects. It is fast and agile. It hunts during the day when its prey is less active due to the heat. It hides in shaded areas using ambush tactics to pounce on its prey. The females give birth to live young in small litters, which they raise in shaded, cooler areas. The young mature quickly, with a high survival rate due to the protective nature of the mother. The next feature we're going to talk about is one that we already discussed previously, which is Flora lumina, better yet known as the glowing heat plant. It's a phosphorescent, fungal-like plant that grows in the twilight regions of Mercury. It glows faintly, emitting a soft light that illuminates the landscape during twilight. The plant's glow comes from specialized bioluminescent cells that react to heat and light changes. Its deep roots extend far into Mercury's crust to access underground ice deposits, which provide the plant with essential water. The pyroflora photosynthesizes and absorbs minerals from Mercury's soil through its extensive root system. The plant grows rapidly during the twilight period when the temperatures are more moderate. It remains dormant during the day and night, conserving energy. It spreads via airborne spores that are released during twilight. The spores are carried by the wind, colonizing new areas across Mercury's surface. Up next, after the pyroflora, we have the Acolytra tenebris, better yet known as the night eagle of the ground. It's a flightless bird-like predator that stands 6 feet tall with feather-like scales that reflect sunlight. Its scales are made of heat-absorbing materials that allow it to remain warm during the long, cold night. Its beak is sharp and designed for turning into flesh, while its talons can easily cross bones. It feeds primarily on smaller herbivores like the Cerasterium, but also scavenge and steal kills from other predators. It hunts during the twilight and night, using its excellent night vision to track prey. During the day, it seeks shelter in the large craters or rocky outcroppings to avoid the intense heat. It breeds in the shade of large craters, where it lays large, heat-absorbing eggs. This egg incubates over Mercury's long day-night cycle. The next creature we're going to discuss is Siderochelis glacies, better yet known as Iron Shell Tortoise. Siderochelis is a large tortoise-like creature with a heavily armored metallic shell. It grows up to 3 feet in length and is known for its slow movement and high endurance against Mercury's harsh conditions. Its shell is made up of a highly reflective metal alloy that disperses solar radiation. Underneath, a layer of insulating material protects its soft body from the extremes of both day and night. Chirocalis has adapted to conserve water and energy, with the ability to go long periods without eating or drinking, storing water within its body. Primarily a herbivore, Chirocalis feeds on small plants like Paraflora lumina, which grows in the twilight zone. It also consumes microorganisms found near ice deposits. Chirocalis is solitary, slowly grazing throughout the twilight period and retreating to underground burrows when the temperature rises. It spends most of its life near craters or ice patches where water is more accessible. The females dig shallow nests near cooler areas where they lay a small number of large hard-shell eggs. The eggs are incubated by the fluctuating temperatures and hatch during the next twilight. The final creature we're talking about today is the Lucidoptera caloris, better known as the Sun Moth. The Lucidoptera is a large, rapidly colored moth with a wingspan of about 3 feet. Its wings shimmer and change color based on the intensity of the sunlight, serving as a biological solar panel. The wings of the Lucidoptera are covered with tiny scales that absorb and store solar energy, providing the moth with the power needed to fly even during the cold nighttime periods. Its body has a thin but tough exoskeleton which insulates it from the heat during the day and cold during the night. The Lucidoptera feeds on nectar-like secretions from Pyriflora lumina. It also absorbs moisture from the atmosphere, making it well adapted to Mercury's dry conditions. Active during the day, the Lepidoptera migrate across the surface, following the day-night cycle to feed and reproduce. It rests during the night, using the stored energy from the sunlight to stay warm. The female lay clusters of eggs beneath the rocks, where they are protected from direct sunlight. The larvae that emerge are nocturnal and feed on microorganisms until they metamorphose into adults. In Mercury's hypothetical ecosystem, each of these species play a crucial role in maintaining a delicate balance between survival and habitation. In the extreme environment, Ignifelis ardens is a swift and agile predator that hunts during the twilight periods, targeting creatures like Siderochelis, glacies, and Aquatilla tenebris. Its heat-resistant skin allows it to survive Mercury's harsh temperatures, and as well as a top predator help propagate the population of the herbivores and smaller creatures. Meanwhile, Siderochelis glaciers, the Iron Shell Tortoise, roams near the craters and ice patches, feeding on the hardy vegetation provided by Pyriflora lumina. Its metallic, reflective shell protects it from the intense solar radiation, and it functions as a key herbivore that contributes to the ecosystem's plant's life balance. Lucidoptera caloris, the sun moth, is a vital pollinator of Pyriflora lumina, a plant that thrives in the twilight zone, where conditions are less extreme. By transferring pollen between these resilient plants, Lucidoptera ensures the survival and spread of vegetation, which in turn sustains herbivores like Siderochelis and Aquatilla tenebris. The latter, a burrowing creature, helps aerate the soil and create underground water networks, ensuring plants and microorganisms can access scarce moisture. Together, these species form an interconnected web of life where predators, pollinators, and herbivores interact to sustain the ecosystem in Mercury's harsh twilight zone, balancing the flow of energy and resources in this extreme environment. Our journey through Mercury's strange and imagined ecosystem isn't over yet. In our next episode, we'll uncover the final five creatures of this world, each more fascinating than the last. What other secrets could Mercury hold? Join us next time as we continue to explore the unknown. And as always, stay curious.